Holy cow, it's been a while guys, but we're still here, I'm still here. It's just been like 6 weeks, I've got college, leave me alone. Anyway, we are at 600 subscribers somehow. That's absolutely insane considering my last video we were only at 200, so thank you so much for the support. Alright, in today's video we're going to be starting on the framework of the omnidirectional treadmill. This includes finishing the Omni wheels and connecting up the drivetrain for the 3 main horizontal rollers. So hopefully that goes pretty good. So first things first, we need to start on the omnidirectional roller that we touched on back in episode 5. Basically, I went through several iterations of this design and it was quite irritating trying to find the right one, but we eventually did it. This design uses metal rods instead of the original dowels, as the dowels didn't offer enough strength. And let me tell you, these were a nightmare to cut. So I ran it through a bandsaw hoping that it would just be able to nicely slide through the beautifully cut steel, and this is all that happened. A little nick in the surface really, just got rid of the mark I made. Completely ridiculous. And that's when I knew I had to pull out the big guns to cut this stuff. Well, even though that was completely and utterly terrifying, we managed to get it done. And we also used this cool air sander to bevel all the edges down and make sure everything was nice and smooth. So now that you know how I made this Omni wheel, let me explain to you exactly how this thing works and functions. This is an Omni wheel. As you can see, it works much like a normal wheel would, except it's got wheels within wheels. These wheels can travel in one of 2 directions, just like a normal wheel would. But along with this, the whole wheel itself can also travel one of 2 of these directions. So if the wheel was pushed towards me, the wheel would simply, one of these wheels would just roll against the ground instead of the whole wheel just flopping over on its side, which would happen if it was a normal wheel and unsupported. But what is so interesting about this, and how is it able to support so much weight? So let's say weight is applied from up top. This force is going to be applied straight down, but as you can see, it goes over this open air, causing this extrusion to bend outwards. But having metal rods and all of these other things in place is going to stop that bending and generalize the force towards the metal tube in the center, making sure that all the force is evenly applied out, which is quite useful. So overall, this design should be able to support roughly 400 pounds of force, which is quite amazing considering each of these is only going to need to support half of the person's body weight for this system to work. So I really hope this system is the final prototype, as I have spent way too long working on it. I would also like to give a huge shout out to KitKat for helping me conceptualize and finalize the design for the omnidirectional wheel. So here is the Omni wheel on the pipe that I'm going to be using, but how are we going to spin the pipe itself? Oh, I'm so good at making segues. So here's the horizontal drive belt for the omnidirectional treadmill. We're going to be building the pulleys that are going to be connecting them to the pole and creating some ball bearings to hold the poles up, because obviously they can't be connected to the frame themselves. And we are also going to be designing a belt tensioner, because as it stands, there will be nearly no force transferred to the belt in the center. So let's get right to work on the pulley design. Here's what I have so far, so we're gonna go print that out and see how it works. So here it is completely printed out. This is the bigger one that I tested initially, and honestly it looks horrendous and it doesn't work that well. All the grooves just weren't made very well and weren't printed with high enough quality. So I printed a much smaller and more manageable one that should be much better for this final design. This will allow the force transfer from the motor to transfer to the pole. So the next thing we need to work on is adding tension to the belt, because currently as it stands, this center belt right here is not going to receive very much tension at all, because there's nothing connecting to these outer edges right here, which basically means it's not going to work very well. So we need something to draw these belts down towards each other to give more connection surface area to this center pulley. So we need to do that for both of these and make a nice fluent design that isn't going to completely ruin everything. So here's the design I've came up with. Basically, instead of pinching it with springs and such, we're simply going to push the belt right through the center of these 2 rollers that will be on ball bearings, and this will be connected to the frame, and it will pinch both of these belts directly center-wise to give more surface area to this main roller right here, and we're going to put them on each side. If needed, we can double them and put them closer to the rollers to give even more surface area. So after a bit of 3D printing, we can finally see what this is going to look like in real life. So we'll simply glue these together and then run the belt straight through the center. So after it's fully assembled, you can see the full design. We've got ball bearings to spin these center bits that will be running against the belt. So now let's go put this on an actual design so I can show you exactly how it's supposed to look like. Here it is. So once we connect it to the frame itself, it's going to look a whole lot better than this, but as you can see, it's pretty obvious how the belt tensioner will work now, and I hope that really explains the whole thing. It does look like I'm going to have to use 2 belt tensioners, but that's okay. Before we start assembling the frame, we have to make a ball bearing or a way to let all of these rollers spin, because as it stands now, they'd just be connected to the frame, which wouldn't work at all. So here's the plan. We've got 2 different ideas. We could just buy ball bearings big enough to fit inside of the metal tube, or we could get creative with some Fusion 360 design, and honestly, I think I'm going to do that with some smaller ball bearings. So here's the design idea. Basically, we're going to take dowel rods and put them through each of these holes with ball bearings in the center. This will create a nice little nestled area for the pipe to sit in right here. It's a bit hard to explain on Fusion 360, so I'm just going to print this out and show you guys in the real world. And there we have it. I've now printed out 4 of these small mock-up designs, and these are slightly different from the ones I just showed you, but basically once they're fully assembled, they should look exactly like this. Basically, this will allow us to nestle the pipe in the center, acting as more of a makeshift ball bearing. So as you can see, we can put the pipe directly in the center, it snaps into place nicely, and then it can roll, which is really useful, and it's a lot better of an idea than simply shoving a ball bearing in the center of it. As it stands right now, I don't have the stuff to make the whole frame yet, and I don't want to wait another 3 weeks to release this video, so I'm just going to show you guys a quick little prototype of what the frame will hopefully end up looking like. And it's really just a mock-up, but I hope that's okay. I'm so sorry that I wasn't able to complete it in this episode. So here's a sneak peek of the frame so far. Basically, I've just done a quick prototype mock-up with aluminum extrusions. Obviously, it's not going to be like this, and we're going to be using the rolly things that I just showed off. But as you can see, we've got the motor up here connecting to one of these belts, and then the tension belt connecting to all 3 of the rest of the poles. Now, one of the issues is that these poles can't actually support the weight of a human, so I've got to order more poles and resize them, which that's going to be a fun time. Anyway, as you can see, this should give you a rough idea of what this is going to look like. We can cross compare to the CAD design real quick so you guys can get a bigger picture. But hopefully this whole frame will be built in the next episode, and hopefully that next episode will be out in roughly 2 to 3 weeks. No promises though. Anyways, I hope you guys all did enjoy today's video. If you want to join the Discord, I'll leave a link to that in the description. And as always, potato in the comments, boys.